In the late 1980s, 6 of the world's top 10 semiconductor companies were Japanese. One of them, NEC Corporation, had even surged past America's Intel to become the largest chip maker on the planet. The idea of Intel being dethroned in the chip business might seem unthinkable now, but 40 years ago it happened. How did a Japanese conglomerate briefly outshine the inventor of the microprocessor? And how did Intel fight back to reclaim the crown? This is the story of the original chip war, a fierce 1980s rivalry between Intel and NEC that reshaped the global semiconductor industry. It's a tale of two very different strategies colliding amid an intense US-Japan trade clash. On one side, Intel bet its future on the microprocessor, the brains of the personal computer. On the other, NEC and its fellow Japanese firms doubled down on memory chips, the high-volume workhorses of electronics. Each approach had its moment in the sun. Each came with huge risks, and their head-to-head battle would set the stage for today's tech landscape. Let's dive in. By the early 1980s, Intel and NEC stood as giants in the semiconductor world, but with starkly different identities. Intel was a Silicon Valley wunderkind founded in 1968 by Robert Noyce and Gordon Moore. It had made history in 1971 by creating the world's first microprocessor, the 4-bit Intel 4004. Throughout the 1970s, Intel introduced one breakthrough CPU after another, 8008, 8080, 8086, and so on, rapidly establishing itself as a leader in microprocessors. These tiny computers on a chip would soon power everything from calculators to the emerging personal computer, PC revolution. Intel's success with chips like the 8086 even helped fuel the growth of Silicon Valley itself, turning the company into one of America's tech darlings. Ironically, Intel's original business was not microprocessors at all, but memory. In its first decade, Intel made its name selling DRAM and other memory chips, products that store data. In fact, Intel once held nearly a 100% share of the memory market in the 1970s. But as the 1980s dawned, that rock-solid grip on memory was about to be pried loose by foreign competition. Enter Japan. NEC Corporation, short for Nippon Electric Company, was, and is, a sprawling Japanese conglomerate with roots dating back to 1899. By the 1980s, NEC was a heavyweight in everything from computers to communications. It had launched Japan's first popular domestic PCs, the NEC PC 8000 series, and was a top 5 global PC maker by 1990. Crucially, NEC was also a semiconductor powerhouse, especially in memory chips. Along with fellow Japanese firms like Fujitsu, Hitachi, and Toshiba, NEC had invested massively in chip manufacturing capacity and technology. The company's semiconductor unit grew so large that by 1985 it was the world's #1 chip maker by annual revenue, surpassing all American rivals. This was a stunning achievement. From 1985 through 1992, NEC reigned as the top semiconductor company on Earth. The stage was set for a confrontation. Intel, the inventor of the microprocessor and once a memory champion, versus NEC, the memory chip juggernaut from Japan. The two companies embodied a broader US versus Japan tech rivalry that was heating up fast. American firms had dominated the semiconductor industry in the 1960s and 70s. But Japanese corporations, often aided by government initiatives, were catching up and, in some areas, pulling ahead. Nowhere was this shift more evident than in memory chips, which were the lifeblood of the industry in terms of volume. By the early 80s, Intel and NEC found themselves on a collision course. Intel still sold memory chips, but struggled to keep up with Japan's aggressive advances. At the same time, Intel was pinning its hopes on its microprocessor business, a segment that was innovative and high margin, but not yet the bulk of semiconductor revenue. NEC, on the other hand, was charging forward in DRAM, dynamic random access memory, the basic memory chips used in countless devices. DRAMs were a commodity product, but Japan's superior manufacturing meant they could produce them more cheaply and reliably, grabbing market share. This wasn't just a corporate duel, it was playing out against the backdrop of a brewing trade war. US officials grew increasingly alarmed as Japan's share of the semiconductor market exploded. The once invincible American chip industry was suddenly in trouble. And at the center of that storm were Intel and NEC, each a symbol of their nation's tech prowess. The good times never last. That phrase rang true for Intel in the 1980s. After a boom year in 1984, the semiconductor market hit a horrific downturn in 1985. It was the worst year the industry had ever faced, not because of a general economic recession, though one had occurred earlier, but because of Japanese competition in chips. Nowhere was the pain more acute than in memory chips, Intel's once core business. Global DRAM prices collapsed by 60% within a year as Japanese firms flooded the market with high-quality, low-cost chips. Demand wasn't the issue. The world was buying more memory than ever. But oversupply and fierce pricing drove profits into the ground. Intel, National Semiconductor, Texas Instruments, all the American players were bleeding. In 1985, Intel had to endure one of the largest layoffs in its history. Intel's memory market share plummeted to a mere 1.3% by 1985, and the company lost over $100 million in 1986 alone. The situation was dire. What was Japan doing so differently? The short answer: better manufacturing and strategic focus. Japanese semiconductor companies like NEC had made manufacturing excellence a mantra. Their factories achieved higher yields, percentage of good chips per batch, than American fabs, meaning Japanese chips were not only cheaper, but often more reliable. Engineers from Hewlett-Packard famously found that Japanese process quality was far ahead of US firms, a shocking realization for Silicon Valley. By 1982, Japanese companies quietly overtook the US in global memory market share, and they never looked back. By 1987, Japan held an astonishing 80% of the world's DRAM market, essentially dominating the memory industry. In that era, 6 or 7 of the top 10 chip makers in the world were Japanese. This was a dramatic power shift. NEC was leading the charge. Its strategy, along with other Japanese firms, was to master high-volume production of memory chips, leveraging scale and automation. The Japanese government actively supported this push. For instance, Japan's MITI, Ministry of International Trade and Industry, launched its VLSI project, and later a Sunrise project in the 1970s to bolster semiconductor R&D. Generous funding, low-interest loans, and tax incentives flowed to firms like NEC, helping them build cutting-edge fabs and develop new process technology. This coordinated effort paid off. Japanese DRAMs became world-class. Culturally, Japanese companies also emphasized quality and continuous improvement, the famous Kaizen philosophy. They implemented rigorous quality control at every production stage. Defects were not tolerated. Any defect was unacceptable, and quality was everyone's responsibility, recalled Tadashi Sekimoto, a former Fujitsu executive. Such an attitude meant Japanese chips earned a reputation for reliability. NEC and peers could thus win over customers with both price and quality. Another advantage for NEC, it was part of a giant Keiretsu conglomerate. Unlike Intel, a relatively focused company that mainly made chips, NEC was a diversified electronics empire. It built everything from PCs and mainframes to telecom systems. This vertical integration gave NEC a buffer against the semiconductor cycle's ups and downs. As consultant Kenichi Omai observed at the time, Japanese chip companies are wholly owned divisions of giant electronics companies that can weather bad times by relying on other profitable divisions. Because they are diversified into many related businesses, they can absorb the peaks and valleys of the chip cycle. American companies are not so well diversified. They have to take hard decisions, Omai explained. In practice, this meant Japanese firms could endure a price war much longer. If memory prices tanked, a company like NEC could sustain losses and make up profits elsewhere, rather than abandon the market. For Intel, however, the peaks had turned to valleys with no soft landing in sight. By 1985, CEO Andy Grove and Chairman Gordon Moore were grappling with an existential crisis. Intel's core memory business was hemorrhaging money as it failed to match Japanese prices or quality. You execute on the wrong strategy, you sink. You don't execute on the right strategy, you sink. Grove later reflected on that period. He admitted Intel had been late on several memory technology generations and underinvested in new fabs. Now, the combination of wrong strategy and fierce execution by rivals had Intel on the ropes. Something had to give. In mid-1985, during a conversation in Intel's office, Andy Grove reached a breaking point. He famously turned to Gordon Moore and posed a make-or-break question. If we got kicked out and the board brought in a new CEO, what do you think he would do? Moore didn't hesitate. He would get us out of memories. Grove stared back and said, "Why shouldn't you and I walk out the door, come back, and do it ourselves?" This moment has since become Silicon Valley legend, the moment Intel decided to quit the memory business and reinvent itself. It was a drastic pivot, abandoning the very products that had founded the company. Yet, as Grove later recounted, there was no viable option. We had become marginalized by our Japanese competitors. There really was no viable option for us to work our way out. The defining business of the company had not hit a pothole, but an ultimate wall, and we had to make a very desperate move, he wrote. The decision was gut-wrenching. It would mean years of pain, plant closures, layoffs of thousands of employees. In fact, by the time Intel fully executed this retreat from DRAM, roughly 1/3 of the company's headcount and operations were gone. But in that crucible of 1985, Grove and Moore realized that only a radical change in strategy would save Intel from going under. Thus, Intel began its retreat from the memory market to refocus entirely on microprocessors. It wasn't an instantaneous switch. Intel still had some memory products like EEPROMs, reprogrammable ROM chips, for a while. But the writing was on the wall. Intel would no longer fight the Japanese head-to-head in commodity DRAMs. Instead, it would pour its resources into designing and selling the brains of the PC, the x86 microprocessor line, like the 16-bit 80286 and the new 32-bit 80386 introduced in 1985. At first glance, this might have seemed a risky, even desperate gambit. In the mid-1980s, memory chips were still a bigger market than microprocessors by revenue. NEC's rise to number one was evidence of that. It was driven by huge sales of DRAMs. Could Intel really survive by focusing on a narrower segment like CPUs? But as history would show, the bet paid off. The personal computer market was on the cusp of explosive growth. IBM's PC, introduced in 1981 with Intel's 8088 CPU, had kickstarted a standard platform. By the late 80s, clones of the IBM PC were everywhere, all built around Intel's x86 architecture or licensed second-source copies of it. Each new generation of microprocessor, 286, 386, 486, brought leaps in performance, and customers were willing to pay premium prices for these chips. Unlike memory, microprocessors weren't interchangeable commodities. If you had a leading design, you could enjoy fat profit margins. Intel was about to demonstrate just how lucrative that could be. Meanwhile, NEC and the Japanese continued to excel in memory through the late 1980s, but not without challenges. The chip war between the US and Japan had escalated beyond just market competition. It became a geopolitical issue. American companies and industry groups, like the Semiconductor Industry Association, co-founded by Intel's NEC, accused Japanese firms of dumping chips at below cost and of shutting US products out of Japan's market. There was some truth to these claims. Japanese DRAM makers, with help from MITI, had kept prices in Japan high while selling at cut-rate prices abroad. They could endure losses longer thanks to easy financing from Japan's big banks, part of the Keiretsu system, and government subsidies. US companies, by contrast, faced high interest rates in the early 80s and lacked such coordinated support. As a result, many American chip makers were simply unable to compete. One by one, they dropped out of the memory business or went bankrupt, leaving only a couple of US survivors, notably Micron Technology and TI, by decade's end. The pressure on policymakers mounted. In 1986, the US government struck a deal with Japan, the US-Japan Semiconductor Trade Agreement. This pact aimed to stop the dumping and pry open the Japanese market for American firms. Japan agreed to set a floor on chip prices to prevent under-cost dumping and to target an approximately 20% market share in Japan for foreign, mostly US, semiconductors. It was an unprecedented intervention. The immediate effect was to stabilize prices somewhat, giving US memory makers a lifeline, and to increase US chip sales in Japan modestly, though reaching 20% took several years. The agreement was controversial. It's often cited as a classic 1980s trade tension, but it signaled how high the stakes had become. This was the first modern chip war, with government and industry joining forces in the US to combat Japan Inc. For NEC, these external pressures meant their free rein in the US market was curtailed. Yet, NEC still enjoyed booming demand worldwide for memory. By 1988, its semiconductor revenues were so strong that it held onto the #1 ranking globally. In 1990, Japanese companies occupied 6 of the top 10 spots in worldwide chip sales, a dominance no other country or region has matched since. It seemed that the Japanese strategy of patient, manufacturing-led growth had triumphed over the Americans' early lead. However, beneath the surface, the tide was starting to turn. Intel's gamble on microprocessors was about to yield tremendous fruit. In 1985, Intel introduced the 32-bit 80386 CPU, a chip that would become a cornerstone of late 80s and early 90s personal computers. By 1987 to 1988, as the industry recovered from the mid-decade slump, Intel's revenues and profits roared back, driven by the uptake of its microprocessors in the exploding PC market. The company's shift from memory to logic chips also forced it to up its manufacturing game. Intel adopted a copy-exactly approach in its fabs to catch up on yield and quality. In essence, Intel learned from the tough lessons of the war with Japan and improved its execution. On the Japanese side, a few clouds appeared on the horizon. The late 80s saw the Japanese asset bubble inflating. When it burst in the early 90s, it weakened some of Japan's industrial momentum. Moreover, new challenges emerged in memory. South Korea's Samsung and others were entering the DRAM arena by the 1990s, threatening the Japanese incumbents with even lower costs. Memory was proving to be a perpetual boom-bust cycle, and the busts could be brutal. One Gartner report later noted that memory price booms are inevitably followed by busts that make it hard for manufacturers to justify heavy investments. So, by the end of the 1980s, Intel and NEC had effectively traded places in terms of optimism. Intel was surging, having executed one of the most remarkable strategic pivots in tech history. NEC was still on top in revenue, but facing looming challenges and increasingly constrained to memory and Japan-centric markets for growth. The stage was now set for the next chapter of the rivalry. A direct clash not in the marketplace, but in the courts, one that underscored the technological stakes of this war. While Intel and NEC were dueling via business strategy and national trade policy, they also found themselves in a bitter legal battle that came to symbolize the intellectual property struggles of the chip industry. This was the fight over microprocessors, specifically whether NEC had illegally copied Intel's CPU designs. It all revolved around NEC's V-series microprocessors, and it would drag the two companies into courtrooms on two continents. NEC's V20 microprocessor, pictured here, was a clone of Intel's 8088 CPU, marketed in the 1980s. It was pin-compatible with Intel's chips and even added some improvements, making it an attractive drop-in upgrade for IBM PC compatibles. Intel, however, alleged that NEC's design copied the internal microcode of its x86 processors, sparking a high-profile legal dispute. The trouble began in the early 1980s. Back in 1979 to 81, when IBM was selecting a CPU for its personal computer, Intel had actually licensed other companies as second-source manufacturers for its 8086 and 8088 processors. This was common practice. Customers, like IBM, demanded a backup supplier in case the primary had issues, so Intel struck deals with firms like AMD and NEC to produce clones of the 8086/8088. NEC was thus initially an authorized second source, producing chips labeled MUPD 8086 and MUPD 8088 that were essentially Intel designs. However, NEC took an unusual approach. Instead of using Intel's blueprints directly, NEC reverse-engineered the chips. They examined how the Intel CPUs worked and then designed their own functionally equivalent version from scratch, or so they claimed. NEC's engineers, led by Hiroaki Kaneko, even studied Intel's original microcode, the low-level code embedded in the chip, during development. Intel was not pleased. In 1982, just a couple years after NEC started selling 8086/8088 equivalents, Intel sued NEC for the first time. The charge, NEC's versions of the 8086 and 8088 infringed Intel's copyrighted microcode. This was novel legal territory. Could the code inside a microchip be protected like software or literature? Rather than an immediate courtroom showdown, that 1982 case was settled out of court. NEC agreed to license certain designs from Intel. Effectively, Intel forced NEC to pay up for the right to keep selling those initial clones. But NEC wasn't backing off the microprocessor market. Far from it, they were about to double down with new products that would push Intel's buttons even more. In 1984, NEC unveiled the V20 and V30 microprocessors. The NEC V20 was a drop-in replacement for Intel's 8088, the CPU used in the IBM PC, and the V30 likewise for the 8086. These chips were binary compatible with Intel's, meaning they could run the same software and fit in the same sockets. In fact, they were not just imitations. The V20/V30 included some improvements, such as the ability to execute older 8-bit 8080 code and certain new instructions, and they ran about 20 to 30% faster at the same clock speed due to clever design tweaks. Tech enthusiasts found that swapping an Intel 8088 for an NEC V20 gave a quick performance boost to early PCs, a popular hack at the time. From Intel's perspective, this was alarming. It wasn't just that NEC was selling compatible chips. NEC was arguably outdoing Intel at its own game by offering a superior 8088 variant. And Intel suspected that NEC's cleanroom engineering might not be so clean. The concern was that NEC had copied Intel's microcode, the internal instruction set implementation, outright, violating Intel's intellectual property. So in late 1984, Intel struck back with another lawsuit, this time squarely targeting the V20 and V30. The allegation, copyright infringement, that NEC's microcode for these CPUs was a rip-off of Intel's 8086/8088 microcode. If Intel could prove this, it would set a powerful precedent and potentially block NEC from selling its clones. The legal battle that followed turned into a multi-year saga, weaving through US courts and even involving filings in Japan. It became one of the first major tests of how IP law applies to microchips. A central question was, is microcode a program protected by copyright? Intel argued yes. The microcode, which is essentially a low-level program stored on the chip to help execute complex instructions, should be treated like software. NEC's defense hinged on 2 points. First, that Intel might have forfeited some of its rights by not properly marking its code as copyrighted when giving it to second-source partners. Second, that NEC had created its own microcode via cleanroom reverse engineering, making it an original work. The case dragged on, and both sides presented piles of technical evidence. NEC showed that its engineers had developed at least one version of microcode, independently a so-called Rev 2 microcode, to demonstrate originality. Intel pushed for the idea that similarities were too strong to be coincidence. In a landmark ruling in 1989, the US court issued a nuanced verdict. The court agreed with Intel on principle that microcode is a protected computer program under copyright law. This was a big deal. It established that the code inside a chip is not just hardware behavior, but can be seen as a literary work fixed in silicon. That set a precedent for future cases. However, the court found that Intel had partly undermined its own case by neglecting to mark its copyrighted microcode on all its chips and licensee agreements. In essence, Intel's handling of second-source arrangements meant it had forfeited some copyright claims, since earlier partner-made chips didn't carry proper copyright notices. Most importantly, the judge determined that NEC did not simply copy Intel's microcode. The evidence showed enough differences in NEC's V20/V30 microcode, especially in the later revision, that it was deemed an original, non-infringing work. The court accepted NEC's cleanroom defense, the idea that NEC's team had independently created their code through permissible reverse engineering. In the end, Intel lost the case. NEC was cleared of the copying charges and allowed to continue selling the V20 and V30 freely. For NEC, this legal victory affirmed that they could legally clone Intel's architectures, as long as they didn't literally copy the code. For Intel, it was a setback. Their attempt to swat down a rival through the courts largely failed, aside from establishing the general principle that chip microcode is protectable. However, there's an ironic footnote. By the time this lawsuit concluded around 1989, the market had moved on. The V20 and V30, which were essentially 1970s-era CPU designs, 8088/8086 class, were becoming obsolete. Intel's own 8386, and soon the 486, were the new stars, powering more advanced PCs. NEC's V-series never extended fully into those higher generations. They did make some attempts at 286 level and up chips, but none caught on globally. Moreover, the legal uncertainty during the mid-80s had somewhat hampered NEC's clone business. Many computer makers were reluctant to use a chip embroiled in litigation. As a tech commentator quipped, NEC's V20/V30 ultimately left more of a legacy in the law books than in the marketplace. They proved a point, but they didn't topple Intel's growing dominance in CPUs. Still, the Intel versus NEC microcode case was a landmark. It set precedents about what is fair game in cloning competitors' chips. That cleanroom approach would be used by others, for example, AMD in later years, to create x86-compatible processors legally. It was part of the fierce head-to-head battle between Intel and NEC, adding legal drama to the commercial rivalry.